So remember, now we're on the third part of ossification. This is what occurs from adulthood, the rest of our life. So the remodeling is going to occur continuously, and we've already learned that it's regulated by mechanical signals, but it's also regulated by hormonal controls. These are negative feedback loops that control blood calcium levels. And calcium is super important in the body, not just in the bone, but it's also important for nerve transmission, muscle contraction, as you'll learn about later in the semester, blood coagulation, which you'll hear about next semester, as well as gland and nerve secretion, and even cell division, which you heard about back in the cell chapter. So, the main hormone that controls calcium balance is PTH, which is parathyroid hormones produced by the parathyroid gland in response to low calcium levels. So you need to know that PTH stimulates osteoclast that reabsorbs or resorbs bone. Calcium is released into the blood to raise the levels, and that secretion stops when the calcium levels are reached. Kind of the antagonistic hormone to this would be a hormone called calcitonin. And calcitonin is in the thyroid gland. It responds to high levels of blood calcium. The effects are kind of negligible, but at high doses, it can lower calcium levels temporarily. So that's the hormonal part. So if we could kind of summarize this first part of the slide as the hormonal control, the second part of the slide would be the mechanical stress. And this is primarily weight bearing exercises as the muscles pull on them. So, this kind of explains why astronauts, their skeleton is going to atrophy because there is no weight that's bearing on their bones. So, they actually have to do an extreme amount of exercise to put stress on their skeleton while they are in space. So our next slide is going to show what PTH does, and it's kind of what I already showed a little bit in the last video, but it's a negative feedback system. So the normal calcium homeostasis should be around this. You don't have to remember that number, but when it falls below that, the stimulus is falling calcium levels. It signals the parathyroid gland to release PTH. I want you to notice that this entire gland is the thyroid gland, and the thyroid gland primarily controls your metabolism, but some of those cells actually release calcitonin. But on the posterior side of the thyroid gland are these parathyroid glands, which release PTH. So PTH is released. That activates osteoclast cells. And osteoclast cells, remember, are responsible for calcium withdrawal. So, again, I think it helps to think of that bank analogy, but it's calcium withdrawal from the bones. And that is basically bone resorption. So, it's converting that calcium into soluble forms, which would be this, to go into the blood, and now we have reached homeostatic control. So the next topic is on bone repair. So fractures are breaks. During youth is when most fractures occur because of trauma, because those bones are not yet completely ossified. In old age, most result from weakness of bone due to bone thinning. So there's really three either or fracture classifications. The first one is whether or not the position of the bone ends after a fracture. So it's either non displaced, which means it retains a normal position, or displaced, where the bones are out of alignment. The second classification is the completeness of the break. So if it's complete, it's broken all the way through. If it's incomplete, it's not broken all the way through. And then finally, the third classification is whether the skin is penetrated. If it's an open or compound fracture, the skin is penetrated. If it's a closed or simple fracture, the skin is not penetrated. And then we can also describe fractures based on the location, the external appearance, and the nature of the break, which we'll see next. So these are the various fractures that you need to know. There's many, many others, but these are the only real important ones. So we're going to go over these 6 here. The first one is called a comminuted fracture, where the bone fragments are broken into 3 or more pieces, and it's particularly common in older bones where the bones are brittle. The next one is a compression fracture, where the bone is crushed, and it's common in porous bones, which kind of mean weaker bones. So an osteoporotic bone. So something subject to extreme trauma like a fall. And we can see that this vertebrae has been crushed. But thankfully, they can do a procedure where they can actually rebuild the vertebrae. I've had a friend who this happened to, falling off a ladder. The third one is called a spiral fracture, where the ragged break occurs when there's excessive twisting forces, and it's a common sports fracture. So one example is a football injury where the cleats get stuck in the astroturf. So unfortunately, the football player kind of continues, but their foot stays stuck in the astroturf. The fourth one is an epiphyseal fracture, where the break is in the epiphyseal plate, so there's separation between the epiphysis and the diaphysis. And it tends to occur when the cartilage cells are dying or the calcification of the matrix is occurring. The fifth one is called a depressed fracture, where the bone is pressed inward, and it's typical of a skull fracture. So this one here looks pretty nasty on the x-ray, where you can see it's been pressed inward. And the last one is called a green stick fracture. And if you think of a green twig and how it breaks, that's exactly what it is. So the bone breaks incompletely, much in the way a green twig breaks, and only one of the shaft breaks, the other side bends. And it's common in children whose bones have relatively more organic matrix and are more flexible than adults. So the way in which these fractures are treated is through, first of all, reduction, where there's realignment of the broken bones. So if it's closed reduction, the physician can manipulate it to correct position. If it's open, it's going to require surgical pins or wires to secure the ends. Then immobilization, where the bone has a cast or traction for healing. And then the time needed repair kind of depends on the break severity, the broken bone, and the age of the patient as well.